I'm Brian Henderson. I work on problems in nuclear security. Specifically, I'm a physicist by training, and so I work on applying the techniques from experimental nuclear and particle physics to modern problems in nuclear security. I was a physics undergrad at Rice University, and I was always interested in doing nuclear and particle physics. So when I came to graduate school, I started at MIT on a project called Olympus, and that was sort of a medium energy particle physics experiment studying the structure of the proton. Towards the end of my PhD, what I knew I wanted to do was to get into something a little bit more applied, looking for a place where I could apply the techniques, the experimental techniques from nuclear and particle physics to something with immediate impact, and this postdoc provided a great opportunity. I work on two major projects as part of the Laboratory for Nuclear Security and Policy here at MIT. One is a project involving the detection of nuclear materials in cargo. Perhaps a more modern nuclear threat is the stealing of one of these a device and smuggling it into the United States, into a port via a cargo container. And ever since 9/11, there has been a big push to develop means for detecting such weapons or smuggled materials in cargo, but it turns out to be an extremely difficult problem. It turns out that just the sheer volume of cargo containers presents sort of an engineering problem on its own. So you have to come up with solutions that are very quick, are operable in the field, so they're very robust, they're not likely to break. And so we're working on a new approach to this, using a new method of generating the beams that are used to scan the cargo, which will hopefully lower the radiation dose, make them easier to deploy in the field, and come up with a new way of detecting any possible nuclear materials stored in cargo. The other project is sort of a longer-term future project looking at a different kind of nuclear threat. Nuclear treaties in the past, when you think of the START treaty, etc., they have never actually involved the actual dismantling of warheads. And a big part of why this is true is because most treaties require some sort of verification. Dismantling warheads is a bit of a trickier proposition in terms of verification, and that's because neither country, imagine if it was a treaty between the United States and Russia, neither country wants to share the engineering details of their actual nuclear warheads with the other country. So this is an interesting problem in that you have to come up with a way to verify that a warhead presented for dismantlement as part of a treaty is actually a real nuclear warhead, that there's no chance to cheat and substitute out something in. This isn't an actual real warhead. So that is something we're working on here.